Hi, I'm Aristoteles Pitaridis. In this video, we are going to use Entity Framework using the code-first method in order to store and retrieve data. We create a new ASP.NET MVC project. We give the name code-first to our project. In an ASP.NET MVC project, there is a folder called Model, where we store all our models. In order to create a model, we just have to create a new class using the name that we want the model to have. We are going to create a model for the students of a school. We right-click on the Models folder and we select the class command from the Add submenu. In the name text box, we type the word student and we click the Add button. Visual Studio created the class for us and automatically it is included in a namespace which has as a name the name of the solution followed by the name models. Now we are going to add some properties to the student's class. The first property is the student ID, which will be used as a primary key for the table that Entity Framework is going to create. The next properties are the name and the surname of the student. We are not going to add more properties so that we will keep it simple in order to make it easier to understand. In order to make Framework able to identify the model that we created, we have to build the application, so we right-click the name of the project and select the Build command. Now we are going to create the controller and the views for the model so that we will be able to edit the contents of the data. We right-click the controllers folder and select the controller command from the Add submenu. The Add Scaffold dialog box will appear on the screen with a list of different types of controllers that we can create. Because we want to use Entity Framework for data access and we also need the system to automatically create the views for us, we will select the MVC5 controller with views using Entity Framework option and we click the Add button. The Add Controller dialog box will appear on the screen. We type the name of the controller so that it will be Students Controller. From the Model Class dialog box, we select the name of the model, which is Student. The next information that we have to select is the DataContext class, which can be used to query from a database. There is one DataContext class with the name ApplicationDBContext, which is created in order to store the users and roles for the site. In order to create a new data context for our model, we click the New Data Context button on the right side of the drop-down list. The new data context dialog box will appear and there is a text box where we can define the name of the new data context. We leave the name codefirst.models in the beginning, which is going to be the namespace for the class, and we change the name of the class so that it will be MyDBContext and we click the Add button. In order to finish the creation of the controller and the views, we have to click the Add button at the lower right corner of the dialog box. As we can see, there is a new controller in the Controllers folder with the Student's controller name. We also have a new class in the Models folder, which is the DataContext class that the framework created for us. If we see the views folder, we will see that the framework created automatically 5 views in the students folder, which will be used in order to manage the data. Let's execute the application in order to see how it works. In order to use the students controller, we have to add it at the end of the page URL. The index action will display a link which will allow us to create a new student, and there is an empty list of students below the create new link. The list is empty because there is not any record in our database yet. Let's add a new record by clicking the Create New link. The framework will display the Create view, and a form will appear with 2 of the 3 fields that we have in our model. The framework is clever enough to understand that the student ID is the primary key of the table, and we do not have to type any value for this field. It will automatically give a unique value each time we add a new record to the database. In the text box, I will type my name, which is Aristotelis. In the surname text box, I will type my surname, which is Pitaridis. When I click the Create button, a new record will be automatically inserted in the database, and the application will redirect to the index action in order to display the list of students. Let's add one more record. We can see that for each record there are 3 options. The first link will allow us to edit the contents of the record. The second link will display the details of the record without giving us the possibility to edit them, and the last link will allow us to delete the record. Let's go back to the project so that we will explain what really happened. We open the DataContext class that the framework automatically created for us. We can see that the class inherits from the DBContext class. We have the constructor of the class where we define a value called name, and we give the name of the data context that we created. This name is the ID of the connection string that the framework created for us. If we open the webconfig file, we will see this connection string, which points to a file in the data directory. We can change the connection string if we want to use a different location for storing our data. This file is located in the app_data folder. For some reason, the folder is empty. This is because Visual Studio supposes that the database is an external file. In order to be able to see the database file, we will have to click the Show All Files icon, and we will see the database that the framework created automatically for us. If we double-click on the database file, we will be able to navigate and find our table and see the fields that we have defined in our table. Let's go back to the DataContext class. After the constructor, there is a public property which is an empty framework DB set of type student. This property will be used by the controller in order to access the data. We will have one property like this for each of the models that we have in our data context. We will see more complex data context classes later. Let's see the controller where all the magic happens. At the top of the class, we create an instance of our DataContext class, which will be used by the actions in order to have access to the data. All the actions have a comment above the declaration which give us an example of a URL and the method which will be used in order to fire the action. The first action is the index, which is the default action, and the only thing that happens in this action is to supply the view with the list of all the students. If we right-click on the index action and select the Go to View command, we will be able to see the contents of the index view. At the top of the view, we can see that there is a definition for the type of the model so that the view will know how to handle it. In the view, we can see that the action link HTML helper is used in order to generate a link to the create action so that we will be able to create new records. Below, there is a table where we can see that the display name form HTML helper is used in order to display the titles of the fields, and the display for HTML helper is used in order to display the value for each field. The for each loop allows us to display an HTML table row for each of the records in our table. For each row, we use the action link HTML helper in order to generate links for edit, details, and delete actions for each record. The second action in the student's controller is the details. It takes one parameter, which is the ID of the record. We get a copy of the student with a specified ID and we send it to the details view. We have the same logic in the other actions. We ask data from Entity Framework, or we can make changes to the data and ask Entity Framework to save the changes. Some actions have two copies. For example, the first definition of the edit action gets one parameter, which is the ID of the student that we want to edit. We find the student and send it to the equivalent view. When the user makes the changes to the edit form and clicks the Save button, the system will call the same action using the post method. In order to define the logic, we have added the HTTP post attribute to the action, which will inform the framework that the action will get a student using the post method. If the method is valid, then we save the changes to the database and we then go back to the index view. If the model is not valid, then we display the edit view again using the student that the system supplied us with. In the post version of the edit action, we can see that there is an attribute called validate anti-forgery token. This is useful because a hacker could hack our page and send invalid information to the action. When we add this attribute, we ask the system to make a check and make sure that the posted data are the data that the user typed. This works by checking if a token generated in a view is the correct token. Let's go to the view of the edit action in order to see how ASP.NET MVC generates this token. We right-click the action and we select the Go to View command. We can see that after the use of begin form HTML helper for generating the form for editing the record, we use the anti-forgery token HTML helper, which will generate the anti-forgery token that we will check in the action when the form is submitted.